I received this kit from IC Station. This is an electronics calculator kit, and we're going to build it and show you guys how this thing works. And it's more than just your basic calculator that can add, subtract, multiply, and divide. This has a few features that I've never seen on any other calculator. Let's check this out. It's been a while since I put together an electronic kit, so this is a brand new one. This one, it looks to be, I think this is a calculator kit actually, still factory sealed. So we'll open this up and see what's in the package. A bunch of parts, including a couple batteries to operate it, some switches, some buttons and button covers. I guess there's a few parts in here, and then there's the main circuit board. I don't know how much of this part is assembled and how much I have to put together. I guess we'll find out once I get the parts out of the bag. Now, calculators these days are pretty simple devices. They pretty much have everything on one chip, and this is no exception. Looks to be there's a bag full of resistors, or not resistors, a couple diodes, a transistor or two, some headers, some battery clips, and I guess just some diodes and switches. And of course the circuit board. And there should be a display in here. There should be a display here. Is it an LCD or is it an LED? It's an LCD display. Excellent. That's all complete. Got a couple of ICs on the back. Okay, let's get to assembly. First of all, the instruction manual, which is printed in full color. The DIY calculator to teach you how to solder if I need that. Comes with screws and everything. It says it's an LCD, so I guess it's an LCD. So we'll get the instructions out here. These are the buttons it's got. Switches, button caps. Screws. All right, let's get assembling this unit. First, I need to install the 5 resistors and 2 diodes. And there are 5 resistors here. Here are the 10K resistors here. And we can see there's a 10K there, a 10K there, and another 10K over here. So we'll install the 3 10K resistors and then do them all kind of in sequence. Resistors are not polarity sensitive, so it doesn't matter what way you put them in, but diodes certainly are. I'll zoom this camera back a bit so you guys can get a better look at what I'm doing. Now people wonder, why would anybody want to put together a calculator kit, right? Because who uses calculators these days? And that's true, because everybody's got one that they carry around in their pocket called their phone. Same with the camera, but it's more just for the fun of doing it. And for some budding electronic enthusiasts, it gives them practice to solder. And that's what these kits are for, to get people interested in putting this stuff together. It's just nice to see that companies are at least still offering kits for things. I'd like to see some higher end kits appear again. Things such as amplifiers and so forth. I've still got an old Heathkit amp that I built many years ago around here somewhere. Don't even know if it works. Okay, that's got the 10K or 10K resistors. Now we got the 1K resistors to go in next. Oh, they've given me 2, but there's only one. So there's only one 330, but they've given me 2 330s, and they've given me 2 1K, but there's actually only one that goes in on here. Okay, so there's a spare part. I was wondering why I had 2 of them there, and there's only one spot on here for it. That's a cat that just wants to play. He's not hungry. He's going to have his toy sitting right at the door, and he wants me to throw it for him. And he's going to sit there and make noise until I either let him in here, which is not going to happen, or I go throw his stuffed toy for him. So maybe I'll go throw a stuffed toy just to shut him up. Okay, he had 2 stuffed toys, not 1, so I threw 1 in each direction to confuse the hell out of him. 3:30 is next. And it goes up here. I have another kit to build here that I picked up a couple weeks ago that I bought, which is called a bulb dial clock. But I'll be doing that at some point in the next little while. I have got to dig up the instructions to assemble that one. I would typically just bend 1 pin over on each corner to hold it in place for the soldering. Ceramic cap here. This is just to filter out any noise that could get into the power line. I think that's all that is. I looked at the schematic, but I'm sure it's just a bypass cap to bypass any RF that might get picked up and cause some issues. I didn't know what the chip that this has got in it. What's it using for a chip? It's a 15W413AS. Obviously a microprocessor that's been programmed. Okay, next I got some diodes to go in. I haven't done the diodes yet. I guess I should do those 2 diodes while I'm at it here. Get the 2 diodes in. These are polarity sensitive, so the band is the negative side, and it's the one marked here on the board with the white stripe. It's got the socket for the display mounted, and now they're telling me to install the microcontroller. I haven't put the transistors in yet. I guess they go in next. It's funny they're asking me to put the microcontroller in before the transistors. I think they got this backwards. They're saying install the microcontroller, but then it says install the transistors, and they're showing the microcontroller is not installed. Next, the 2 transistors and the IC are going to be installed, and they are different. They are numbered, So this is a 9013. It's a, what is it, 2N is it, or 2S? It's an S9013. Next, we'll install the chip, and then the switches all have to go in. So there are a whole bunch of little switches here, little micro switches, little tactile switches that will click, and well, they all just snap into their appropriate points on the board. And the last row. See, the thing is, a cat knows I'm out here because he can hear me talking to the camera. So he knows I'm out here. So he's just going to sit at that door and howl until I go and play with him, because this is a rag doll, this cat, and they're more like a dog than a cat. Like, this thing likes to play fetch. And you play fetch with him for a while, and then he'll get tired and go and do what cats do. Go back to sleep. Go find someplace to curl up and go to sleep. Crash on the couch, in other words. But yeah, he gets very vocal when you don't pay attention to him. All right, that's got the buttons all installed. Now I guess now I can install, because the only thing left to do on here is the microprocessor and the display. So let's get the microprocessor in now. There's a notch on here. It goes, pin number 1, got a notch on it. It goes in that orientation with the notch on the board itself. Put the microcontroller in place and just pop it in. Just like that. All right, now I've got to put the other header on the display, and it also requires a header to be soldered down like this. So the display can be plugged in and angled. So we'll put the header in and solder that down. This kit is taking form quite nicely. It's almost done. What is this P1 up here? I see something that says P1. Alright, now this is ready to plug in. This thing's almost ready to fire up and test. We plug the header in here to the display, to the other socket, and I think it's now ready to install batteries and get it ready to test. And the other cell goes in on this side over there. Oh, there it is. It lights up. Oh, cool. It is lighting up. It is a oh, interesting. It's an alphanumeric type display. It is LCD, but it is a dot matrix type display, which is actually kind of neat. I don't know how it shows up on camera, but there it is there. I guess this is the type of thing you'd have to take apart to change the batteries. And this might be for, actually that might even be for external power, you know. P1 plus and minus. I bet you you could run external power onto this thing. Let's just see if there's any power on here. Yeah, 5.62 volts. That's external power, positive and negative. So you could put a plug on there and put like a 5-volt adapter on here. But yeah, there's the LED right there. So a little LED that light up the backlight. And there's the. Okay, so let's get the buttons put together. We're going to cut down the keys here. So we're just going to cut them down on the line here. Final one. And now we have to cut the individual numbers out and put them into the respective buttons. So let's cut these ones out. We'll assemble all the buttons and then put them on the appropriate keys. So each button cap just fits into the button like that, and then the top of the button or the bottom of the button just snaps in place. Just like that. All right, I've got all the button caps in place. Now I just have to place them onto the keyboard. So we got to look at what order they go in. I'm going to find the correct ones, and we'll start out. We'll just turn them all over the right way first of all, so that we can see which is which. And unfortunately, this one here, I got to take this one apart because when I snapped it together, the paper went in kind of crooked. So we'll just see if I can pull this apart. This might be harder to do this than it was to putting them all together, because my paper did not get centered on this one. I had relative peace there when I was doing this because I wasn't talking, so the cat was quiet. The cat can hear me talking again, and the cat's making a noise. Center the buttons. Make sure that they're all centered when you snap the bottom cover on. Rule number 1. Otherwise you won't be able to read it. Okay. We'll just turn all the buttons over so we know which is which, and then start just putting them on in the proper order. It's kind of like playing Scrabble. Turn all your tiles over. Now we just proceed to snap all the button tops on to their appropriate switches. And I got an arrow is next, the left arrow is next, this one here. And then the power on and all clear. And then 7, 8, and 9 are the next ones. Down here. And the decimal point. And then the other numbers, and then 0, and then, well, you can figure out where the rest of them go from there. 0 is down here. So the buttons are all on, and now it's time to mount it in the cabinet. So you secure the main board with the 4 screws here, and there's a couple more short screws you can secure to display down. The only thing I really see on this that really needs to be addressed is how do you change the batteries when the batteries go dead? There's no hatches, so maybe cut a little hatch in the side here Or put an adapter plug on and just power it up with AC. With a 5-volt adapter would do it, I think. Would work quite nicely. Back cover goes on just like this. Now this is not just an ordinary regular calculator like, you know, that you would use for adding and subtracting. No. This is a little bit more than just a regular calculator. And I kind of kept this for the last here because any electronics enthusiast would appreciate something like this, especially if you're not good at your color codes, because you see this is also a color code calculator. So it will tell you your resistor color codes and what your value is if you're not very good at your color codes. So for example, if I turn it on here, turn it on, there it is, I'll hit mode. Okay, color ring. And then, of course, it'll also calculate out your different calculations. It's got a hex, 10 hex to 16 hex calculator, as well as a regular calculator. So 2 times 6 equals 12, right? It'll do your regular calculations. But if I put it into color ring, for example, orange, red, and then say gold. That's 33.2, but if we got the fifth, it's a 5 band, so 5%. So it'd be 33.25%, right? Clear. Does it do different modes to it, or does it just do the one? This is for the resistor color, resistor capacitor 5 rings. Does it do 4? Let's just see if there's different modes here that this will work with. Error. Because some resistors are 4 band and some of them are 5 band, right? So I don't know whether it so brown, black, silver, 100 ohms, right? 10%. Violet, white, blue, orange, 768K, and then your last band would be silver, would be 10%, or gold would be 5%, or none is what is it? So 796K. So it'll figure out your color codes for your capacitors and resistors, in addition to being a basic calculator. So if you've got voltage here, say 5 volts, and what's the next mode here? I gotta figure out which one, next one over, is this one here? Current, 52 milliamps, and resistance. Shut up! I'll tell you it's 99.04 ohms. Do your calculations. $12 volts. And we'll say 1,000 milliamps. Be 12 ohms, because of course a 12 volt supply at 1 amp would be 12 ohms. So you can calculate out your basic Ohm's law. Again, if we had 120 volts at 5,000 milliamps, because that'd be 5 amps, then your resistance would be 24 ohms. So you can do your Ohm's law calculations, your basic calculations on here as well. Mode, hex, 10 to 16. So you got a calculator, Ohm's law calculator, and a hex converter, 10 to 16 hex, or 16 to 10 probably. It'll do either, right? So your 10 base hex 542 is 21E, and your 16 hexadecimal. Base 10 to base 16, so 2 would be 2, right? 8, 9, right? And then you get to 10, which would be A, 11 is B, 12 C, 13 D, 14 E, 15 F, right? So if you put in 255, that's FF, right? 248, that's F8. You can calculate out your hex conversion to base 10. And of course you can put any number in. So if you put in right, that would be 21E, 88E. You've got, what, 7 digits here? Yeah. So 1, 2, 3, 4, 5, 6, 7 would be 12D, 687. How about 999999? 98967F. As far as the calculator goes, how many keys is it? It's a 7 digits. Oh, weird. Most calculators are 8, but this is 7 digits. Let's just see how accurate this thing is. 12 times 12, 144. It seems to know that. What's the square root of 452? 21.26. Okay, not quite as accurate as my phone. My phone goes to a lot more degrees of decimal, but the square root of 452 is indeed 21.26. And that's rounded down, so it works. Turns itself off after a few minutes to save the batteries. Again, I don't know how long these batteries are going to last on here, but a slot in the side so you can grab them with a pair of tweezers to slide the batteries out and replace them might make it a little more useful, or a little plug on the back, which something I might do is just put a little 5-volt adapter. We'll see how long the batteries last on this thing, but a nice little kit. It only took me less than an hour to put this thing together, and it comes with everything: the case, the button caps, everything you need to put together a little mini electronics calculator that would be a welcome addition on any electronic enthusiast's desk to do simple calculations and figure out those resistor color codes. It tells you here what they are, right? It tells you the colors right here. Brown is 1, 2 is red, orange 3, yellow 4. It tells you them what they are here, but you can punch them in and get a reading on the display. Okay, I think that's about it for this one here. Probably gone on a little long. I wanted to show you guys the build of this. It comes with a couple of extra resistors, like a lot of kits do. But as far as new kits on the market, I think that anybody who's an electronic enthusiast would really enjoy putting something like this together. Hey, you can say you built it yourself, and it certainly is a conversation piece, and a useful one at that. I'm going to put the link to this in the description. It came from IC Station. They sent me this here promo to build for you guys, so now you see it. I think this is a great little kit, easy to do, and looks to be very well thought out, just the way that the circuit board's laid out. The hardest part for this entire kit, believe it or not, was getting the circuit board to line up with all the buttons. And that's why getting the buttons down completely flush when you solder them is very important. One of them here was off by a little bit. I was up when I soldered it in. I wasn't completely flat on this button, so this one was a little bit crooked, and it made installing it difficult. So I had to go back and reheat the buttons on the other, the contacts on the other side, and push it flat, and then it slid right in. So that's something to keep in mind. Anyway, link in the description. Thanks for watching. We'll catch you in the next one. Bye.